do a lesson about integration by substitution. Essentially, this is the way we undo the chain rule. Okay, so this is how we're going to undo the chain rule. So the chain rule comes from differentiation. So let's review that real quick. So remember that if you have something like this, and I give you, it's f of some function u, and if I differentiate that, I take the derivative of f, leave u alone, and then take the derivative of u. So that's what we get when we do the derivative. So for example, let's say I had something like x squared plus 1 cubed divided by 3, and I said take the derivative of this. Well, if we take the derivative of this, what we do is we bring that power down, reduce the power by 1, and then we differentiate the x plus 1. So it ends up with something like that. So that would be how we do the chain rule on a problem like that. Now, when you think about like integration is undoing a derivative, right? So the idea behind integration is we're going to undo a derivative. Okay, so we're going back the other way. So we're going to undo the derivative. So it would be something like this. Now, if you look at this, you go, wow, that's a lot. Well, what we do on this is we do a thing called use substitution, and we just use some, we do this idea behind substitution, inserting one thing for another. So we're going to insert one variable for another. That's what we're going to do with this. So if you have something like this and we do use substitution, we can kind of go, okay, well, let's just let u equal x squared plus 1. And we're just going to use it for the time being. And I don't know what just happened to my screen, so I'm going to pull it back up, and hopefully it will come back up. Just a second. Let's see if I can get that back. Hopefully it came back for you. Not sure why that just froze on me, but it did. Anyway, so here's where we go. So we got this variable u, and we just kind of use it as a dummy variable. Now if we differentiate u with respect to x, we would get 2x. And we can manipulate these things anywhere we want. Like we can multiply both sides by dx, and we can write 2x dx. And all I did was differentiated and then multiplied. Now, if you look at what we have, notice that du is equal to all of this. That purple is equal to the purple, so we could substitute it in there. Notice that u is equal to all of this. So if we wanted to, we could rewrite this original integral as the integral of u to the second power du. Now we just have the power rule for integration. The power rule for integration is that's u to the third divided by 3 plus c, and you've had some practice with that. So now the only thing we have now, though, is notice that u could be put back into there. And so our final answer can be x squared plus 1 cubed divided by 3 plus some constant. Remember, you always got to have a constant when you're doing indefinite integrals because you might have some constant there. Notice that that's the same thing we did on that first problem. If I scroll out, notice that that's what we got. I picked that derivative for a reason. Notice that that's it right there. That's the result. These would cancel out, and we'd end up with the original thing, and that's right there. So that's the process that we're going to do. We're going to do it. It's called U substitution. It's the way we undo the chain rule. We use it with integration. Usually you pick U to be something that when you differentiate it, it's in there again. So we're going to just do a bunch of different examples. And I'm going to run through them, and I'm probably going to run through them relatively quickly. You can come back, and if you need help more, let me know. So if I make U equal to 5x, du would just, du over dx would be 5. So du is equal to 5 dx. Now we're going to end up jumping right from this step to this step on the next one. So we're not going to do that intermediate step next time. But if I just do some more highlighting, and I'll just highlight for a couple times here, notice that that's U. Notice that du is the 5 and the dx. So I could rewrite this integral as the integral, the cosine of u du. And I want to write the du at the end because that kind of closes the integral off. Okay, so I want to write it like this. Don't write integral du cosine u. That's bad. Don't do that. Okay, put the du at the end. It's the proper notation, and you won't really know what you're talking about if you do it the other way. It means something else. So if I have this, the integral of cosine is sine. And then for the sake of getting back to u, I'm going to replace that back in there. So sine 5x plus c. And if you differentiate that, you'll see that you'll get cosine 5x times 5. And that's what we started with. Now I'm not going to do some of this highlighting that I've done before. I'm just going to go through and do some of these problems. So I'm going to speed up a little bit. Not trying to make you crazy by speeding up. I'm just trying to make sure that we get through a lot of problems so you see a lot of examples. So if I make u equal to x squared plus 1, du is equal to 2x dx. Now notice, I don't have a 2 up in here. So if I move the 2 over by making it 1/2 du is equal to x dx, that would be really good. Now I will highlight this one because I worry that if I just jump right out of this one and don't show you where I'm putting stuff, you might freak out a little bit. But notice that that's what I'm going to have. So if I rewrite this, this is equal to the integral of u to the second power times 1/2 du. And remember, 1/2 is just a constant. Like I could write it like this if I wanted to. That 1/2 just goes out in front. I can't get rid of it. It doesn't change my integral. So now this is 1/2 u to the third divided by 3 plus a constant, which in this problem is x squared plus 1 cubed divided by 6 plus a constant. With a little bit of simplification, we go to there. Okay, let me keep going. Something like this one. Remember, this is the same thing as 2x minus 1 to the 1/2. So just remember that that's a 1/2 power in there. So u is going to equal 2x minus 1. So du is equal to 2 dx. I don't have a 2 up there that's floating all alone. So I'm going to make it a 1/2. And now I can rewrite this integral as the integral of u to the 1/2 times 1/2 du. So we got that 1/2. This becomes u to the 3/2 divided by 3/2 because we add 1 to the power plus c. Now if I do a little simplification and I plug u back in, I might get 1/3 2x minus 1 to the 3/2 plus c. And that's because I'd be multiplying by 2/3, and the 2's would go away, and I just have that. So if you're missing that one, check the intermediate step in there. The intermediate step would be 1/2 2/3 u to the 3/2 plus c, and notice those go away, and that's how we get to here. So if you're following the arrows, that's what we would do. All right, so remember that this one is really the sine of 3x squared is the cosine of 3x dx. So if I make u equal to the sine of 3x, that means du cosine 3x times 3 dx because of the chain rule. So if we move that 3 over, we have something like this. And then if we simplify this or plug in u, this is the integral of u squared times 1/3 du. Notice we're using the power rule a lot on this. That's because it shows up a lot on these problems. So if I go over here and I finish it, I would have 1/3 u to the 3rd divided by 3 plus a constant, and you could make that 9 if you were doing if you're simplifying it. You could make it divided by 9 there. All right, you can pause the video and see if you can do these two problems. U equals 3x minus 1. Du is equal to 3 dx. This is the integral of u to the 4th du. So this is 3x minus 1 to the 5th divided by 5 plus c. Over here, u is equal to x cubed minus 2. So du is equal to 3x squared dx. So this is the integral of u to the 1/2 du. So this is x cubed minus 2 to the 3/2 times 2/3 plus c. Little simplification in there. Again, trying to get through a lot of problems so you see a lot of different things. So go back and review it if you don't understand it. Ask me questions if you don't understand it. I'm trying to think this is the last one. So again, if I make u equal to 2 equal to x squared plus x, du be 2x plus 1 dx. So this is the integral of u du, which is u to the 2nd divided by 2 plus c. And finally on this one, if I make u equal to the cosine x, du is equal to negative sine x dx. Notice I don't have a negative 1, so I'm going to move that negative 1 over. That way I account for it. And then I have the integral of the u to the 2nd power times negative 1 du. The negative 1 comes along. This becomes cosine x to the 3rd power divided by 3 plus c. Hopefully that makes sense. If you have any questions, let me know. And good luck.